another. So, example, what is the limit as x approaches, this is kind of interesting, as x approaches 0, that's kind of curious, of e to the 1 over x? Well, this is a number, x equals 0, so we have to do x approaches 0 from above, and we have to do x approaches 0 from below. Well, for x approaching 0 from above, positive numbers headed towards 0, here's what we get. As x gets close to 0, this 1 over x goes to positive infinity, right? As x gets tinier and tinier and tinier, 1 over 1/10, 1 over 1/100th, 1 over 1/1,000,000th, the 1 over x blows up to infinity. So we get e to the infinity equals infinity. So the limit as x approaches 0 from above of e to the 1 over x equals positive infinity. Now, for x approaches 0 from below, well, as x approaches 0 from below, so x is a negative number. That means 1 over x goes to negative infinity, right? X is a negative number. It's getting closer to 0, but it's still a negative number. So 1 over x is a negative number. So it's going to end up going to negative infinity. 1 over x goes to negative infinity. Well, e to the negative infinity is equivalent to 1 over e to the infinity. 1 over e, as this becomes infinitely large, the 1 over x becomes infinitely small. It goes to 0. So the limit as x approaches 0 from below of e to the 1 over x is actually equal to 0. So you get two different limits approaching a number, one from above, one from below. And again, it's all based on just asking yourself, what happens to the function, or in this case, pieces of the function, and then you use that piece to address the big function when x does something. Use your intuition. Trust your intuition. This is completely intuitive. As I know that x is negative, therefore I know that 1 over x is going to be a negative number. Well, if it gets closer and closer and closer to 0, this is going to be, it's going to go off to infinity, but it's going to go off to negative infinity. E to the negative infinity is the same as 1 over e to the infinity. Well, as this denominator gets really, really big, the function itself, this 1 over, it goes to 0. So let's take a look and see what this. So in this case, so the limit as x approaches 0 of e to the 1 over x, it does not exist. And it does not exist because you ended up with two different limits. One is infinite, one is 0. And again, we said, when you're approaching a number, the left-hand limit and the right-hand limit have to be the same in order for us to say that the limit exists, and the limit is this. A right-hand limit, a left-hand limit exists, it's 0. The right-hand limit, I mean, it exists in the sense that it goes off to infinity. It's not a real number, but, you know, it exists, it goes off to infinity, but the limit itself does not exist. Okay, so let me repeat. And I know you are sick to death of me repeating this. I know. So you see that we are simply asking ourselves, what happens to f of x as x either approaches a number or as x approaches infinity. That's all we're asking. And the reason I keep repeating myself, I apologize, is because sometimes when you're just faced with some function, it's a little intimidating symbolically. So you sort of all of a sudden get a little, get a little intimidated, maybe a little discombobulated, and you're like, well, wait a minute, just what is it asking? It's saying, as x does this, what does f of x do? So just remember that's all this symbolism is. As x does this, what does f of x do? So as long as you can sort of contain that, you can calm down and address the issue as you need to. And it's really very, essentially, it's simple. I mean, the hardest part in taking limits is going to be the manipulation part. How do I manipulate the function in order to actually be able to take a limit and get something that makes sense? It's always going to be the hardest part of calculus, is going to be the manipulation of the algebra, not the calculus itself. So in any case, that's that. So if our, let me see, yeah, I'll go ahead and write this out. So if our first attempt is nonsense, when we take the limit, is nonsense, then we manipulate and try again. Until we get f of x actually approaches an actual number, or we get f of x going to positive or negative infinity. And if it doesn't work the second time when you take the limit after you've manipulated, try another manipulation. Try it again. You keep trying until one of these two things happens. Either you end up with an actual number when you take the limit, or you end up with positive or negative infinity. That's when you can stop. Okay, so let's try this time the limit as x goes to positive or negative infinity of e to the 1 over x. So now it's not x approaches 0, but it's x approaches positive or negative infinity of e to the 1 over x. So let's see what happens here. Well, as x, let's see. Yeah. So as x approaches positive infinity, so let's go ahead and write our function again here. F of x equals e to the 1 over x. Actually, let me write the entire limit. We wanted to know what the limit as x approaches positive or negative infinity was of e to the 1 over x. So as x approaches positive infinity, well, 1 over x goes to 0. So e to the 1 over x, e to the 0, it approaches 1 from above, positive numbers. Now, as x approaches negative infinity, well, again, 1 over x definitely approaches 0. Okay? 1 over x approaches 0, with 1 over x being negative values. So e to the 1 over x is equivalent to 1 over, you know what, that's fine. Let me make this more clear. So as x goes to negative infinity, this 1 over x, it goes to 0 through negative values, right? Because if x is a negative number, then 1 over x is a negative number. Through negative values. So e to the negative 1 over x. No, you know what? I don't want to do that. So we're still dealing with e to the 1 over x, e to the 1 over x, except now these 1 over x's are negative numbers, right? So that's going to be equal to 1 over e to the 1 over x, where now these are positive. And e to the 1 over x, we said that it approaches 1, so this is going to approach 1 over 1, so it's going to be 1 from below. The moral of all of this is just keep track of all the details. That's it. Just be really, really meticulous in what it is that you do, and everything should work out. So let's take a look at what this particular thing looks like. So this is our function. So here our function is e to the 1 over x. Well, as x gets really, really, really big positive, we said that the function itself is going to approach 1. This dashed line is our horizontal asymptote. It is y equals 1. As x gets really, 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 really big negative, well, 1 over x is definitely going to be negative. It's the same as 1 over e to the 1 over x. It's going to also approach 1 from below, but notice it never becomes negative because this is never a negative number. So it approaches it from below, but it's still positive numbers in the sense that, so 1 over x is negative, but e to the 1 over x, which is what this function is, it approaches 1 from below. So in this case, there's only one horizontal asymptote. It's y equals 1. Okay. The lesson is basically this. There is no one way to evaluate every limit. Oops. And that's it. That's pretty much what it comes down to. So this is reasonably sophisticated mathematics. And as things become more sophisticated in mathematics, it's no longer going to be algorithmic. There's a certain degree of algorithm where if you do this, but each problem is going to be different. So you have to bring all of your resources to bear, whatever those resources are, whether they be graphs, tables, analytics, some trick that you learned when you were 10 years old, whatever it happens to be. All of these things have to be brought to bear as weapons against these particular problems. So there's no one way to evaluate every limit. So don't think that you're supposed to just look at a problem and know how to do it. The process of mathematics is not looking at it and just automatically knowing what to do. If you fall into that trap, then when you're faced with something that's slightly different than what you're used to, you're not going to be able to handle it. So always try to keep a reasonable degree of objectivity. Keep an open mind. And don't worry that all of a sudden when you look at something, you don't know how to do it immediately. Knowing how to do something immediately is not a measure of intelligence. Intelligence has to do with being able to look at a situation and work the situation out. This is sophisticated mathematics. It isn't 1 or 2 steps. There are going to be some problems in calculus over the next year that you're going to multiple steps. You're not even going to know where it is that you're going. You're going to have to trust that each step you take is a reasonable step, and you're going to have to hope that it's taking you somewhere. That's what it's about. It's about getting to the answer in a reasonable, logical way. Even if you don't know exactly the path that you're following, could be a very circuitous path. So in any case, so there's no one way to evaluate every limit. Use every resource at your disposal. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.